Get your free copy of the complete tutorial at www.teachucomp.com/free.
Access is a relational database application. So what does the term relational mean, and how is this important? The term relational describes the method used for storing data within the database tables. However, it may be easier to understand the relational model of data storage by contrasting it with another method of storage that you may be more familiar with. That would be the flat file method. Information is frequently stored in large flat files or single tables. For example, assume that you want to create a database file that stores your company's customer information. You would begin by listing the different attributes of the customer that you wish to record. You may want to record customer information such as the first name, the last name, the company name, and other relevant pieces of information. Perhaps you could create a table in an application like Microsoft Excel, where you can create columns for each piece of information that you wish to record. You can then list each customer's information in the rows underneath the columns, creating a basic table. Let's assume it looks like the example shown on screen. Now, for many types of databases, this structure shown would work well. This is a flat file list or table. What you are doing when you are using this type of database is recording a single piece of information, like the first name, last name, or address, about a single entity, in this example, a customer. The reason that this type of data structure works well in the example given is because for each entity, meaning the customer, you are only recording information that has a one-to-one relationship to the entity. So, what does this one-to-one relationship between the entity, the customer, and the data that you are recording, such as first name, last name, and so on, mean? What this means is that for each entity or subject, in this example the customer, you are only recording information about that entity for which there would be only one answer. So, for example, each customer would only have one first name and one last name. They would only work for one company. So the term one-to-one refers to the relationship between the subject of the table, which is customers, and the data being recorded about the entity. Because for each one customer, there is only one possible piece of data to record in the column. The relationship between the data and the entity is one-to-one. If this is the type of database that you're trying to create, simple Microsoft Excel tables will work well. The problem occurs when you try to use a flat file approach to model a more complex entity or subject, like sales. For example, assume you wanted to expand the customer database from the last flat file database to include sales data. Now, in addition to the information already being collected, you want to record each customer's sale. First, you would start by listing what data about each sale that you want to record. Keeping the example simple, assume that you decide to record the sale date, the items purchased, the quantity of items purchased, and the amount paid for each item purchased. In that case, you may decide to add the following columns to the flat file data structure. This may appear to work at first glance. However, you will immediately begin to encounter problems once you begin to enter records into the file. To begin with, each time a customer makes a purchase, you must re-enter all of the first name, last name, and other customer information again. This alone is irritating enough. However, you will also soon run into another problem. What do you do when a customer purchases multiple items in an order? One solution often proposed at this point is to enter another row with all of the redundant information for each item purchased. However, you will find that this file will grow quite quickly down the table, and you will also have to enter a lot of redundant customer data for each item purchased. This is not an elegant solution and will inevitably waste data storage space as well as the time and effort of the person who performs data entry. Another solution often proposed at this point is to create additional columns like Item 1, Item 2, Item 3, Quantity 1, Quantity 2, Quantity 3, and so on, instead of having to enter additional rows of information. While this may seem like a good alternate solution, what will you do when someone purchases 100 items? Will you really create a set of 3 columns, item, quantity, and amount, for each item purchased, producing a table over 300 columns across? Would you simply leave those columns blank if the person orders only one item, wasting valuable storage space? In this solution, you are simply substituting columnar growth across for vertical growth down. So this is not an elegant solution either. So then you might think, why is there a problem now when there wasn't one earlier? And the answer is that now you are no longer trying to model a one-to-one data relationship within the table. Recording sales information is simply more complex than recording customer information. What you are trying to record now is what is referred to as a one-to-many relationship. Basically, for each entity, the customer, you are now trying to record data within the columns, which could occur more than once per customer, meaning the items ordered. You would be in a sorry state if each customer could only purchase a single item. So you must allow for the fact that in a sale transaction, each customer may order many items. The relationship between customers and items purchased in a sale is a one-to-many relationship. When you find that you are trying to model a one-to-many relationship, it is then that you must abandon the flat file method of data storage, where you try to place all of the information that you want to record into a single table, and instead turn to the relational model of data storage for the solution.
Like what you see? Pick up your free copy of the complete tutorial at www.teachucomp.com/free.